Okay, good morning, students. I am going to start the class. Is it clear? My voice is appearing clearly now. Okay, now I am going to start the class. You listen very carefully. If you have any doubt, you can ask me while teaching. And you write in the chat box. Now we are going to start the. I am going to explain the gravitation chapter. What is gravitation? This some basics related to this gravitation you learned in the ninth class only. What is gravitation and what is gravitational force? What is gravitation? Can you tell? Gravitation or the gravitational force. It is the force of attraction. The force of attraction. Force of attraction between any two objects. The force of attraction between any two objects is called as gravitational force. Gravitational force is the force of attraction between any two objects. Okay, that is called as a gravitational force. Now, this gravitation force in this gravitation chapter, what we are going to discuss? We are going to discuss about the how planets revolves and what is the speed of the planet and what are the satellites, how many types of satellites are there, and how with how much force Earth attracts the other objects, and some properties we are going to discuss regarding the gravitational force. Okay, universal law of gravitation and some other topics we are going to discuss. First of all, I am going to explain the universal law of gravitation. What is universal law of gravitation? You learned in the previous class, right? What is universal law of gravitation? Universal law of gravitation. The universal law of gravitation is it is given by the scientist Newton. What is Newton's universal law of gravitation? Newton's universal law of gravitation is, according to this, any two objects in the universe are attracted with each other. That attraction force depends upon some points that is given by the Newton scientist. That is the Newton's universal law of gravitation. Then, according to that, if any two objects are there, their masses are m1 and m2. Okay. For example, this is an object whose mass is m1, and this is another object whose mass is m2, and they are separated by a distance r, and there exists some force between these two objects. Okay, this m1 body attracts the m2 towards left side, and m1 m2 body also attracts the m1 towards right side. They are attract with each other. They are attract with each other. This attraction force, this attraction force depends upon some factors. That is, the attraction force is depends upon the masses and depends upon the distance between the two particles. That is, according to this, every body in the universe attracts the another body, or any two bodies in the universe are attract with each other. Every body in the universe attract another body with some force. This force is directly proportional to the this force is directly proportional to the product of masses. This force is directly proportional to the product of masses, and inversely proportional to the square of square of distance between two particles. Distance between two bodies. Okay, right. This is our universal law of gravitation. It is given by the famous scientist Newton. Okay, right. This is called as Newton's universal law of gravitation. According to that, what we said here, any two bodies are attracted with each other. This attraction force is directly proportional to the product of masses. That means we write here force is proportional to the, what do we write here? The force is proportional to the product of masses. We write F proportional to M1, M2. Okay. And one more, we write a force between these two objects is inversely proportional to the square of distance between them. That is F inversely proportional to R square. If we combine these two formulas, then we will get as F proportional to M1, M2 by R square. When the proportionality is removed, we will get a constant, that is capital G into M1 M2 by R square. Okay, this is the formula for force between any two objects in the universe. What is capital G here? Capital G is the universal gravitational constant. Universal gravitational constant. What is M1 M2? M1 M2 are the masses of two bodies. Masses of two bodies. Okay, right. What is a small r? Small r is the distance between centers of two bodies. Okay, we have to take the distance between the two bodies, but that we have to measure from the centers. Okay, center from the center of mass, distance between centers of two bodies. That is the universal law of gravitation. And there is a value of capital G. Okay, there is some value is there for the capital G. You must remember it. That is 6.67 into 10 to the power of minus 11. There is a new unit is there, Newton meter square per kg square, right? And one question I want to ask for you, whether force is a vector or scalar. I want the answer in the chat box. Very simple question. All the members should give the reply. You take the screenshot and note it. Okay, right. Right. The next one is capital G unit, and we have tried some dimensional formula. Okay, what is the unit of the capital G and what is the formula for the capital G? Capital G is what actually? Universal gravitational constant. Universal gravitational constant. Universal gravitational constant is the capital G. Then, what is the formula for the capital G? Right? You know, according to the universal law of gravitation, the force formula is F is equal to capital G m1 m2 by r square. From this, if you write the capital G formula, we will get as F r square by m1 m2. Right? We have to take r square to left side. You have to take m1 to left side. You have to take m2 to left side. You should follow the cursor which is in the which is appearing on the screen. This is the formula for the capital G. Based on this formula, we have to write the unit. That is capital G unit is, yes, can you tell? Force unit is Newton, SI unit. Distance unit is meter, meter square. By mass m1 is kg, m2 is kg, we write as kg square. Newton meter square per kg square is the unit of the universal gravitational constant. Can you write the dimensional formula? Can anyone write the dimensional formula? What is the dimensional formula of capital G? Dimensional formula. What is dimensional formula? There are some fundamental physical quantities are there. What are that? Mass, length, time, temperature, quantity of substance, luminous intensity, right? The electric current. There are 7 fundamental physical quantities: mass, length, time, temperature, quantity of substance, luminous intensity, and electric current. They are indicated by with these terms. These terms are called as the fundamental physical quantities, and you can express any other physical quantity that is just like capital G also we can express in these terms in mass, length, time, temperature, mole, like this. Then how we can express? Force is the mass into acceleration, right? Acceleration is what? Velocity by time, change in velocity by time. Now here we write velocity is what? Displacement by time. Velocity is what? Here displacement by time. Displacement will come in the length, right? Length by time. Like this, LT inverse is a dimensional formula. Time is t. Time is t. LT inverse is a dimensional formula of velocity. Okay. And acceleration is what? Change in velocity by time. Change in velocity is LT inverse dimension formula, and time is a t. Then we will get LT power minus 2. This is acceleration. Acceleration expressed in length and time. Velocity expressed in length and time. Okay. Here we write force formula, mass into acceleration. And here we write mass into acceleration is change in velocity by time. Otherwise, directly we can write mass into acceleration. Mass is m, already fundamental. Okay. A is we got here LT power minus 2. Like this, the force dimension formula is mlt power minus 2, we write, into r is the distance. Distance will come under the length. L square we have to write. Distance r is L. R square is there, that's why L square. By m1 is the mass. Mass is m only. Right? M2 is also mass. Mass is m. Right? In the dimension formula. We have to express these fundamental quantities. We have to express these quantities. Okay. F, R, M1, M2 in terms of fundamentals. Fundamentals are the 7. Right? And if you write, simplify this, we will get M inverse. This one m will cancel, m goes to numerator, m inverse you will get, L into L square you will get as L cube, and t power minus 2. Have you understood now? This is the dimension formula of capital G. Dimensional formula means what? We have to express any physical quantity. Physical quantities are what? G is a physical quantity, F is a physical quantity, M is a physical quantity. Force, mass, acceleration, velocity, displacement, heat energy, work, power, impulse, whatever the thing that is measurable physical quantity, anything that can be measured is called as a physical quantity. That physical quantity you can express in terms of fundamental physical quantities, that is called as dimensional formula. This m inverse L cube t power minus 2 is the dimension formula of capital G. Right? What is the dimension formula of the force? Force dimension formula is mass into acceleration. Mass is m. Acceleration dimension formula here we derived. Change in velocity by time. Change in velocity is here we derived. Velocity displacement by time. Here we wrote L t inverse. Time is t. M acceleration dimension formula is L t power minus 2. Force dimension formula is ml t power minus 2. If you want work, force into displacement. Force is ml t power minus 2. Displacement is what? Displacement come under the length. We write here is ml square t power minus 2. This is learned in the units and measurements chapter, right? Okay. Students, is it clear? Write in the chat box, students. Is it clear? Write in the chat box. Is it clear now? Okay, right. Good. Now going to start. Continue. We got the capital G unit and dimensional formula, right? Okay. And now one question I want to ask. What is acceleration due to gravity and what is its CSI unit? Next topic is the acceleration due to gravity. What is acceleration due to gravity? Can anyone write the definition of acceleration due to gravity? And what is its value? Write in the chat box. Right. Next topic is acceleration due to gravity. Acceleration due to gravity. What is acceleration due to gravity? Gravity means what? Due to earth, right? Gravity means earth. Due to earth, if any body has acceleration, that acceleration is said to be acceleration due to gravity. Due to earth, can anybody have the any body has acceleration? Right? Due to earth, acceleration means what? Acceleration is also physical quantity. Right? Acceleration is also physical quantity. Acceleration is the rate of change of velocity. Acceleration due to gravity. It is denoted with a small g. Okay, its definition is very simple, right? That is the acceleration of freely falling body. Acceleration of freely falling body due to gravitational force. Acceleration of freely falling body due to gravitational force. Acceleration of freely falling body due to gravitational force is called as acceleration due to gravity. Acceleration due to gravity. Can you tell what is the value of acceleration due to gravity on surface of earth? You see here, this is the earth. Okay, this is the earth. And this earth on the surface of earth, this earth has the mass capital M. Okay, if you left free any object above the earth, it will fall down. Right? It acquires some acceleration while falling down. That acceleration means what? Change in velocity by time. Change in velocity by time. When you left free any object on the at a height certain when you left free any object at certain height from the ground, that object will be fall down. While falling the object, its velocity is increases. Its velocity increase means the change in velocity, increase in velocity by time. For every second, how much velocity increasing? That is called as acceleration. Then that acceleration is produced. Why the velocity of freely falling object is increasing? Because of earth attraction force, right? The earth attraction force means because of gravity. Because of gravity, this object having the acceleration. That's why it is called as acceleration due to gravity, right? What is the formula to find out the acceleration due to gravity on surface of Earth? Write in chat box. Okay, let us continue. Acceleration of freely falling body due to gravitational force is called as acceleration due to gravity. Okay, and acceleration due to gravity, on what factors it depends? Okay, it depends upon the, for example, if you want to find out the acceleration due to gravity on certain planet, okay, and acceleration due to gravity on certain planet, on what factors it depends? Acceleration due to gravity depends upon some factors: height, height above the earth surface, we can find out the acceleration due to gravity on certain planet. Okay, on the earth I will find out acceleration due to gravity. Acceleration due to gravity on surface of a planet I want to find out. Okay, how to find out the acceleration due to gravity on surface of a planet? For that, what we have to do? We have to take a planet. For example, this is a planet. This planet has mass capital M. This planet has radius capital R, and above this planet we are keeping one object. Okay, look at here. This is an object. This object mass is a small m. Okay, and now this object is pulled down by the gravitational force with some force F. That force acts toward the center of the planet. Okay, and now what is the formula for that force? Consider consider an object of mass small m is on the surface of a planet of mass capital M. Okay, let small g be the acceleration due to gravity on surface of planet. Okay, see here. Is it okay, students? Clear? You are not replying for anything. You write in the chat box. Is it clear, students? Anything missing? Okay. G is the acceleration due to gravity on surface of a planet. Now next, I am going to derive the formula. You listen very carefully. It was very easy. Right. What I am going to derive it here? I am going to derive the formula for the acceleration due to gravity on the surface of planet. Okay. And for the purpose, what is the force on the planet? Force on the object. Okay, gravitational force on the object. According to universal law of gravitation, tell me the gravitational force between these two objects. You see here the picture. In this picture, you see I want the force on this object applied by the planet. Then how we can find out force formula from universal law of gravitation? We can find out very easily. We can find out how we can find out from that. Okay, let us continue from here only. Force on the object of mass m. On this object force I want. Then according to universal law of gravitation force formula, what we write? G m1 m2 by r square, right? This you know already. Force formula is G m1 m2 by r square. M1 is what? Capital M. M2 is a small m by r square. We have to write. And here, this is the formula previously we know, that is according to universal law of gravitation. Force formula, what you know? F is equal to G m1 m2 by r square. You know that formula we have to use it here. G m1 m2 by r square formula. You know, if m1 m2 are the two objects, okay, they are separated by r distance, then the force between these two objects formula is G m1 m2 by r square. This formula we have to write here. This is the object whose mass is small m, and on the surface of Earth, acceleration due to gravity we can consider as small g. And I want the force formula, force on this object, that is capital F. Force formula is m1 m2 by r square g m1 m2 by r square g into m1 is planet mass capital M, and m2 is the object mass small m, and r is the distance between the two objects. That is here distance between the objects from centers we have to take, that we have to take as capital R. No need to take, we are taking from the center of the planet, but we are not taking from the center of the object because the object is very small. Okay, that the central distance is neglected. This is equation 1. And according to Newton's second law also we can write the force formula. What is the Newton's second law? What is the formula for the force in the Newton's second law? Can you tell? According to Newton's second law, what is the formula for the force? Yes, the force formula we can also write as mass into acceleration. This is an object small m and acceleration is a. But here we know acceleration due to gravity on surface of Earth is g. We write here mg. Okay, and from equation 1 and 2, both are for the force only. Then we write as mg is equal to g into capital M small m by r square. We have to write. Okay, you see here both are the for the formulas on the, both are formulas for the force on object applied by the planet. Then left sides are same, then right sides also equal. Small m will be cancelled. Then we will get small g is equal to capital G capital M by r square. This is the formula that is useful to find out the acceleration due to gravity on a planet. Okay, acceleration due to gravity on surface of a planet we can find by using this formula. For example, I want the in this, what is capital G at here? Capital G is, you know already, universal gravitational constant, and if you want, you write here what is capital G, what is capital M. Capital G you write, note it. Okay, capital G is the universal gravitational constant. Capital M is the mass of the planet. Capital R is the radius of the planet. Okay, right. Take it. Take the screenshot. Is it clear, students? Till now? Okay. If you have any doubt, you write in the chat box. Don't hesitate to ask the doubts. Okay, let us continue. And what we derived in the previous case, we derived the relation between the small g and capital G. What is the relation between the small g and capital G? Okay, relation between the small g and capital G is small g acceleration due to gravity on surface of Earth. We derived acceleration due to gravity on surface of Earth. Formula what you got? I want the acceleration due to gravity on surface of Earth. Okay, how we can find out? Acceleration due to gravity on surface of Earth. Baby Mato, Sangeeta Hembram, what are you doing? You are all. Write in the chat box. Acceleration due to gravity on surface of Earth. What is the acceleration due to gravity on surface of Earth? That is, we derived, for example, this is the Earth. In case of Earth, Earth mass is what? For example, acceleration due to gravity on the surface of Earth, we take small g. Earth mass capital M. And Earth radius you take as capital R. Okay, this is the first point in the note. That is, we will get a gm by r square. But in case of Earth, what is the value of Earth? Earth mass is, you know, 6 in 10 to the power of 24 kg. And capital G value, you know, is 6.67 into 10 to the power of minus 11 Newton meter square per kg square. And one more thing also, you know, radius of Earth, right? Radius of R is the radius of Earth, 6,400 kilometers. This is the 6,400 into 10 to the power of 3 meters. Right now, you substitute these all values in above equation. If you substitute here 6.67 into 10 to the power of minus 11, and mass of the Earth is 6 into 10 to the power of 24, and R square 6,400 into 10 to the power of 3 whole square. Now you simplify this, we will get the small g value as 9.8 meter per second square. That means acceleration due to gravity due to Earth is 9.8 meter per second square. Then acceleration due to gravity, for example, at certain height I want to know. For example, this is Earth whose mass is capital M. Okay, this is the Earth whose mass is capital M. And at capital R distance, G formula is gm by r square. For example, I want the distance acceleration due to gravity at smaller distance from the Earth's surface. This is the from the Earth center, not surface. From the Earth center at smaller distance, I want the acceleration due to gravity, small g. Then how we will get that small g? That small g is just simple acceleration due to gravity. Acceleration due to gravity at a distance smaller from the center of Earth. From the center of Earth, small g is equal to, we write as capital G capital M by small r square, we have to write. Okay, this is about acceleration due to gravity. And if you go for the acceleration due to gravity on the moon, okay, on any planet you can find out the acceleration due to gravity based on this. Acceleration due to gravity, acceleration due to gravity on moon is 1 by 6 times of acceleration due to gravity on Earth. Acceleration due to gravity on. This is not appearing, na? I think there is something is going under the photo. You are not telling. You are not writing in the chat box. Oh, I will remove and I will write in down. Up to acceleration, it is appearing, na? Right. 1 by 6 times of acceleration due to gravity. Acceleration due to gravity. Okay. Right. And now that means g on moon is equal to 1 by 6 times of g on air. Right. On the moon, acceleration due to gravity is less because the mass of the moon is less. Okay. Right. Next we will go for the another one. On what factors this acceleration due to gravity depends? That I am going to explain. Factors on which affects the acceleration due to gravity. Acceleration due to gravity will be varies with the height, with the depth, with the latitude. These are some terms on which the acceleration due to gravity depends. Okay, we will discuss now. How acceleration due to gravity varies with the height, that first we are going to discuss. Or first, otherwise we write the some contents, that is on what factors acceleration due to gravity depends. Okay, acceleration due to gravity or due to earth, I am taking, depends upon, okay, what are the points, it will depends. Okay, first one, shape and size of the planet, mass of planet, height from the surface of planet, depends upon the height from the surface, and depth. On the radius also depends. The size gives the radius also. These are some factors, but I am going to explain how acceleration due to gravity varies with the height. Okay, right. And for the purpose, first I am going to explain variation of acceleration due to gravity, variation of acceleration due to gravity with height. How acceleration due to gravity varies with the height, that I am going to explain first. Okay, how we will know that how acceleration due to gravity varies with the height? For that, we can consider as this is a planet, Earth. Okay, Earth or any planet, and now on the surface of Earth, we can take as acceleration due to gravity g. At here, acceleration due to gravity is g, and this is the radius of the planet is capital R here, and from the planet at a distance, certain height we are taking. That height is h. At this height, I want the acceleration due to gravity. At this height, the acceleration due to gravity is considered as gh. Okay, and the planet mass is capital M. Planet mass is capital M. First, I want to write the formula for the acceleration due to gravity on surface of Earth. What happened? Acceleration due to gravity on surface of Earth or any planet. What is the formula? G is equal to, we know, capital G, capital M by, we have to take the surface, means surface distance you have to take from center, okay? That is capital R. We have to write as Gm by R square. This is equation 1. I want the acceleration due to gravity. Acceleration due to gravity at a height h I want. At a height h. Then how we can find out that? At a height h from the surface of Earth. Then for that it was very simple, you remember it. If you want acceleration due to gravity on the surface, you see the picture. On the surface, if you want the acceleration due to gravity, then you have to take the distance from center to the surface, that is capital R we wrote. If you want the acceleration due to gravity at h height, then you have to take the h height distance from the center, because in the gravitation all the distances measured from center only. Gm by, we write r plus h whole square, we have to write. This is equation 2. And now we have to divide these two equations. From equation 2 also we say one thing, right? Whether when the height increases, whether acceleration due to gravity decreases or increases. When height increases, this r plus h we can also consider as a smaller, right? If you consider it as smaller, then you will get a gh is equal to gm by small r square. Then we write here gh inversely proportional to small r square. Is it right? When small r increases, what happens? Gh decreases. When smaller increases, if the height is increases from the surface of Earth, this is smaller increases because smaller is r plus h only. When height increases, smaller increases. When smaller increases, Gh decreases. That means we can write acceleration due to gravity decreases with increase in height. Acceleration due to gravity decreases with increase in height. Acceleration due to gravity decreases with increase in height. Okay, when height increases, r plus h increases. When r plus h increases, dh decreases. Right? Acceleration due to gravity at a height h we are considering as gh. Then height h means height h distance we have to take, that is gm by height h point distance. The point which is at height h, its distance from the center is r plus h. We have to take r plus h. Then gh equal gm by r plus h whole square we will get. And then after that, acceleration due to gravity decreases with increase in height, okay, from the above equation. We have to divide the equation 2 with equation 1. Okay, equation 2 by 1 you can do. If you do equation 2 by 1, then what you will get? Gh by g. Gh by g. What you will get on the right side? Right side is gh value is gm by gm by gm by r plus h whole square. And g value is what? G value is gm by r square. It will be reverse because by g is there, right? Then r square by gm we will get, right? Okay. Then next, gm cancel it here. The next step what you will get? I'm going to write in the next equation in the next page. You take the screenshot and note it. Okay. Any doubt, students? Till now, is it clear now? Everything? Right. Let us see here. We got this formula. Its continuation I am going to explain now. GH by G is equal to what you are getting. GH by G. GH by G on the right side you got as R square by R plus H whole square we got. I want the GH formula. GH is equal to GR square by R plus H whole square. Can anyone tell what is the small g? What is small g and what is GH? What is the difference between them? What is small g and what is GH? Small g is the acceleration due to gravity on surface of earth. What is GH? Acceleration due to gravity at a height h from the surface of earth. Okay, we have to simplify this. This is the formula to find out the acceleration due to gravity at a height h. We will take in the denominator, we do one thing, that is gr square by, in the denominator r is common at here. If you common the r at here, you will get 1 plus h by r whole square you will get. You do one thing here. R you can common in the denominator. If you common the R, what you will get here? R will 1 remains. Here h by R remains. You multiply again R plus h you will get. R into 1 R. R into h by R h. Right? R into h by R h you will get. R plus h whole square. Now we have to simplify it. GH is equal to, we are getting the GR square by R square into 1 plus h by r whole square we have to write. Okay, this r square will get cancelled. We are getting the one more formula for the GH, that is G by 1 plus h by r whole square we will get. Is it right? This is the formula to find out the acceleration due to gravity at a height h. Okay, this is the formula. I will take some special case, that is, for example, I will do like this. GH is equal to G into, we write 1 plus h by r whole power minus 2 you will get. Okay, and there is some expansion is there, but that is in the mathematics it is there. For example, 1 plus x whole power minus 2 is there. Its expansion will be like this there, 1 minus 2x plus 3x square, something like this. For example, if x value is very less, then x square, x cube values are neglected. At the moment we can write this formula as only 1 minus 2x only we wrote. 1 plus x whole power minus 2 we write as 1 minus 2x. Then this formula we will apply for the above equation, for this equation. Then what you will get? Note it carefully. Alright. What we are telling it here? 1 plus x power whole power minus 2. Here also same thing equation is there. There is a gh is equal to g into. Okay. This is applicable when h is less than r. Okay. We are neglecting the higher order terms now. When x value is less than 1, we can neglect. This formula we will use in the mathematics when x is less than 1. Okay, when x is less than 1, we will neglect the x square and x cube, like that higher order terms are there. We have to expand the 1 minus x power minus 2. In the expansion, higher order terms are neglected when x power 2, x power 3, x power 4, they are neglected when we have to neglect. Then if x value is very less than 1, at the moment x square, x cube very much less you will get. That's why we can neglect, and we can write 1 plus x power whole power minus 2 as only 1 minus 2x. Then here also we have 1 plus h by r whole power minus 2. If h is less than r, that means uh, the height is negligible. Okay, height is negligible. Height is negligible. Very less height. When height is negligible, what you will get? This h is less than r means h by r is less than 1. You will take r to left side, r into 1 you write here, r to left side, then h by r less than 1. When h by r is less than 1, then what you will get? This condition is obeyed. You see here 1 plus h by r whole power minus 2. What we can write here? 1 plus h by r whole power minus 2. Okay, it is similar to 1 plus x whole power minus 2 here. But here this we can write as here x less than 1. If it is, then 1 plus x power whole power minus 2 we write as 1 minus 2x. 1 minus 2x we write. X is what here? H by r. Right? 1 minus 2 h by r we write. This we substitute in this equation. Okay. Then we will get gh as g of 1 minus 2h by r. This is the formula. This formula is applicable only when, okay, when you will apply this formula if h is less than r. Otherwise we should not apply this formula. Okay, and we write the equation numbers. Previously equation number 2 completed. Okay, and next equation number 3. This is equation number 3 and this is equation number 4. Okay, have you understood how acceleration due to gravity varies with the height? Can anyone write in the chat box how acceleration due to gravity varies with the height? Whether it is decreases or increases. If you increase the height, okay, with the increase in height, how acceleration due to gravity changes? With increase in height from the surface of Earth. With increase in height from the surface of Earth, acceleration due to gravity decreases. Acceleration due to gravity decreases. This we discussed. But oh, from this also we can say when h is increases, this denominator increases. When denominator increases, g value decreases. Very simple, right? And now, for example, if you want the change in acceleration due to gravity, if h is less than r for the small heights, for example, you want the change in acceleration due to gravity. From equation 4, we write like this. What you write from equation 4? gh is equal to what you write? G multiply with g minus 2h by r into g we write. I want the g minus gh. I want the g minus gh. You take this gh to left right side, this to left side. Then what you will get? You simplify it. Okay. And then you will get as g minus gh. There is a change in acceleration due to gravity. What you will get here? 2h by r into g you will get. For example, if you want the change in acceleration due to gravity, this d minus gh we can take as delta g. By original value is g. What you will get here? 2h by r we will get. Okay. This is the fraction of change in acceleration due to gravity. This is also applicable for the small heights only, not for the large heights. How you got this one? Gh is equal to g of this formula from equation 4 you multiply with small g. G minus 2h by r into g you will get. Okay. And you take 2h by r into g to left side and gh to right side. Then what you will get? Okay, here I will write gh, sorry, 2h by r into g left side, 2h by r into g. On the right side what remains? Gh is taken to right side, that is g minus gh. Is it right? G minus gh. G minus gh is the change in acceleration due to gravity. Okay, g minus gh. 2h by r into g, here we are writing. Okay, then after the g minus gh we are considering delta g. Delta g equal to 2h by r into g. This g right side, the g we take to left side, then you will get delta g by g is equal to h by r. This is the fraction of change in acceleration due to gravity for small increase in height. That formula is 2h by r, where r is the radius of the earth and h is the height. When the height increases, then acceleration due to gravity decreases. This is how acceleration due to gravity varies with the height. Now we will discuss more 10 minutes how acceleration due to gravity changes with the depth. We will discuss and then we will close today's lecture. Okay. Okay, let us see. Next topic is the second point of variation of acceleration due to gravity with the depth. Variation of acceleration due to gravity. Acceleration due to gravity with depth. How we can vary the acceleration due to gravity with the depth? Okay, that I am going to explain now. You listen very carefully. Okay, after 10 minutes I will close. Don't worry. If you have any doubt, you can write in the chat box. Till now, is it clear, students? Write in the chat box. Till now, is it clear? Baby Mato, Kashmir, Suraj. Okay, continuing the topic. Variation of acceleration due to gravity in the depth. And for that, what we have to do it here. Now, this is considered as the earth. On the surface of earth, acceleration due to gravity is small g. On surface of earth, acceleration due to gravity is small g. I want the acceleration due to gravity at certain depth. Okay. At here, I want the acceleration due to gravity. The depth is h. At h depth, I want the acceleration due to gravity. At this depth, the acceleration due to gravity we can consider as g suffix d. Okay. And whether the acceleration due to gravity increases or decreases, that also I want. This is the center of the earth. From the center to this point, this is the radius, right? You know this one. This is the radius. And this distance from this point where I want to find out the acceleration due to gravity, that point distance, that is r minus d we have to take. Why? Okay, don't take this as h. I don't want height. I will take it as depth. We can take it as d. Okay, we can take it as d. At a depth d, I want the acceleration due to gravity. Okay, this is the depth d. This I am taking as depth d. Remember it. Okay, on surface of earth, acceleration due to gravity is g. At a depth d, acceleration due to gravity is gd. I want to find out the gd value, how it will changes. Okay, right. Now remember it. Variation of acceleration due to gravity. This is the planet of mass m. What is the formula for the acceleration due to gravity on the planet? Acceleration due to gravity on surface of earth of mass capital M, earth mass capital M and radius capital R. What is the formula? Acceleration due to gravity formula just we derived starting in the beginning, dm by r square. This we can consider as equation 1. But we don't take acceleration due to gravity at a depth d as from the depth d distance r minus d we should not take like that. There is some changes will be there in its derivation. I will explain clearly. You listen it here. Now, this mass of m is the mass of earth. I want to convert the mass of earth into density. Mass of earth. Okay, in terms of density, I want to write. The mass of earth we write as density of earth density of earth into volume of earth we write. Volume of earth we write. Why? What happening at here? When you want to find out the acceleration due to gravity at certain depth d, in the depth d, the effective mass of the planet is decreases. Actually, when on the surface means the whole earth attracts the object which is on the surface. Okay, the whole earth attracts the object which is on the surface of earth. But if object is at certain depth, only this part at a depth d, okay, there is some radius of earth is there r minus d, then that only attracts the earth. That's why effective mass of the earth also changes. This m also changes, r also changes. That's why we convert into densities. Right, mass of the planet equal to mass of earth equal to density of earth into volume of earth. Mass is capital M, density we can consider as rho, and volume of earth we can take as 4 by 3 pi r cube. This we substitute in equation 1. Then you will get the g is equal to capital G into capital M we write is rho into 4 by 3 pi r cube we have to write by r square we have to write. This r square and r cube will cancel and acceleration due to gravity we will get as 4 by 3 pi g rho 4 by 3 pi g rho r we have to write. This is acceleration due to gravity on surface of earth. We not changed anything. Here also small g is the acceleration due to gravity on surface of earth only. But I want at a depth d. At a depth d. At a depth d from the surface of earth. From the surface of earth. What happens? If you go to at depth d, right, and the effective radius of earth is decreases. At a depth d from the surface of earth, effective mass, that means if object is at here, the whole earth attracts the object. If object is at here, okay, you see the figure, when the object is at the on the surface, the whole earth attracts the surface object toward the center. But when object is at depth d, right, only this part, okay, that part is radius is r minus d. Effective mass of earth decreases, right, at a depth d from the surface of earth. Effective mass means the total earth not attracts the object, only this part we have to take. Effective mass and radius of earth changes. Okay, effective radius changes. Okay, and effective radius becomes r minus d. Okay, when this object, you see the figure, object, when object, you should follow the cursor. When object is on the surface of earth, then the total earth affects the object. When object is at certain depth d, that object is affected by only the part effective mass of earth we have to consider uh, by taking the point where you want to find out acceleration due to gravity as the reference point. You form a circle, you form a sphere. That sphere only affects the earth acceleration due to gravity and affect the mass, affect the object. That's why we have to take only this radius. On the surface means surface radius we are taking. At a depth d means d distance radius we have to take. Then acceleration due to gravity at a depth we have to write like this. If you not understood anything, then now you will understood. Okay, don't worry. Acceleration due to gravity at depth d, we write like this. GD is equal to 4 by 3 pi g rho, we write as r minus d. You see here, on the surface is acceleration due to gravity g, right now? On the surface distance is capital R we wrote here. But at a depth d, we want acceleration due to gravity. GD, that is that at a depth d distance from center we have to take, that is r minus d. That means r is replaced with r minus d. Right, understood now? Okay, good. Now let us continue. Right. Now we have to divide the equation for example, r minus d we can consider as a small r, right? That is, a small r is what? Distance of point where you are finding the acceleration due to gravity from center of earth. Is that right? Then dd, if you write that equation is like this, 4 by 3 pi g rho into small r we can write. From this dd proportional to small r we will get. Okay, dd proportional to small r you will get. When you will divide these two equations, equation 4 divide with equation 2 now. Okay, then when you will divide this, the left side of the equation 4 is gd by left side of the equation 2 is g is equal to 4 by 3 pi g rho into r minus d by 4 by 3 pi g rho r. This will cancel, and gd by g we will get as r minus d by r we will get. This we can also write as like this, r by r minus d by r we write. Is it right? Then we will get gd is equal to r by r is 1. Oh, gd by g is equal to r by r is 1 minus d by r. And you take g to the right side, final formula you will get gd is equal to g of 1 minus d by r. This is the final formula to find out the acceleration due to gravity at a depth d. This is equation 5. Okay, right. Have you understood now? What happened? Whether with the increase in depth, acceleration due to gravity decreases or increases? Hmm? In 2 minutes, I am going to close. Finally, I will tell whether acceleration due to gravity decreases or increases. Acceleration due to gravity, GD. Acceleration due to gravity decreases with increase in depth. Acceleration due to gravity. Acceleration due to gravity decreases with increase in depth. Okay, this is how acceleration due to gravity varies. How I am telling that it will be increases, it will be decreases with increase in. We write here gh is equal to, from equation 5 you got g of this one like this, and we can go for other equations also if you want. gd is equal to what you are getting here, g of r minus 1 minus d by r, last equation from equation 5. Okay, from equation 5, we write like this. You do the LCM. R minus D by R you will get. This depth increases means this R minus D decreases. R minus D decreases means GD also decreases. GD also decreases. Is it right? From this equation we say that. Okay, note now. One graph I want to tell. Okay, and this graph is very important. Acceleration due to gravity on surface of Earth. With height, acceleration due to gravity formula is what? Gm by R plus H whole square, right? Or there are so many formulas are there. Gr square by R plus H whole square, or otherwise G by 1 plus H by R whole square. These are the various formulas that we derived for the height. Variation of G with height. G by we write as what happened? It's not working. G by we write as 1 plus H by R whole square also we write. Okay, these are the various formulas. From this we write when height increases, G decreases. Okay, if you want to write this one from this Gm by, if R plus H is considered as R, we write here GH is inversely proportional to R square we write. G inversely proportional to R square we have to write. In case of depth, what is the formula? GD is equal to G of R minus D by R. Various formulas are there. Okay, R G of 1 minus D by R. From this, if you consider R minus D as R, okay, GD proportional to small r you will get, where small r is the distance from the center. If you draw the graph G versus small r, once again you can watch the lecture for the clear clarity and you can ask the doubts. Okay, only 1 minute I will draw the graph and close. I thought to complete early, but it is taking the time. I will draw the graph at here. Graph between acceleration due to gravity and distance from center of earth. Okay, I will draw and I will close. Distance from the center we will take as the smaller on x-axis. Acceleration due to gravity is taken on y-axis. Then from the center, at the center acceleration due to gravity is what? At the center acceleration due to gravity is what? Can you tell? What is the acceleration due to gravity at the center? At the center of the earth, what is the acceleration due to gravity? What is the acceleration due to gravity at the center of earth? At the center of earth, what is the acceleration due to gravity? This is not working. Alright, what happened? Work. Not working because so much time it is taking. Okay, right now I will close. Acceleration due to gravity at a depth d we can find out by using a formula. GD is equal to g of 1 minus r by d, 1 minus d by r. I want the at a depth equal to radius at center of earth. At center of earth, acceleration due to gravity how much? At center of earth, acceleration due to gravity. This is earth. At center means here I want. Center means depth is equal to radius of earth. Is it right? Then you use the formula acceleration to gravity equal to GD is equal to, we derived 1 minus d by r. Okay, you use the GD into depth is again equal to radius at center means at center acceleration due to gravity how much you will get? That is 1 minus r by r. R by r is 1. 1 minus 1 is 0. Acceleration due to gravity at the center is 0. Then when you will go away from the center, acceleration due to gravity increases and it will become maximum at the on the surface of earth. And when you go increase more height, okay, then acceleration due to gravity decreases. That means here what is this? What we are telling it here? From the center you are increasing the acceleration due to gravity. Sorry, from the center of earth you are moving away. This is the center of earth. From the center of earth when you will go away, right? What happens? From the center of earth acceleration due to gravity 0. It will be increase. On the surface it will become 9.8. Then further if you will increase the height again decreases. This is how acceleration due to gravity varies with the height and depth. Thank you to all. I'm going to close and thank you for your patience. And I think you can watch once again. And if you have any doubt, you can ask me right in the chat box. Thank you to all and thanks a lot. And I'm going to close the class.